Okay, in this video I'm just going to start with the first page of the 6.4 notes on properties of definite integrals. And some of these these properties are all pretty intuitive, and I'm not going to go through trying to prove them, but we'll try to make them make a little more sense. So the first one is that if I have an integral, a definite integral from a to a of f of x dx, that's just going to equal 0. Because you can imagine if I've got a curve, whatever it looks like, if here's my x and here's my y, if I'm starting at a and ending at a, then my area is going to be nothing. There's no area there because it has no width. Given that a is less than c is less than b, then the integral from a to b of f of x dx, well, what they're saying here is that I've got something like this, got a curve, starts at a and a b, and then I've got, in the middle, I've got some c. But what it's saying is that this whole integral from a to b, that whole area, is equal to the integral from a to c of f of x dx plus the integral from c to b of f of x dx. So it's just saying that the whole thing is equal to the two parts. If the integral from a to b of f of x equals k, then the integral from b to a, going backwards, is going to be negative k. Why is that? Well, because if we're going, again, if we've got a curve and we're going from b back to a in this direction, then the width of if we imagine little rectangles, right, our integrals making little rectangles here, the width of each of those rectangles is going to be negative. So it's going to just flip the sign of whatever we got when we went from a to b in the positive direction. Same thing here. If b is less than a, it doesn't actually matter that b is less than a, but the integral from a to b is always equal to negative integral from b to a of f of x dx. And this rule 4 here is really saying the same thing as rule 3. Now, 5 and 6 are some sort of basic rules of sort of algebraic rules, how you deal with integrals. Like, for instance, if I have the integral from a to b of k times f of x dx, I can think of that as equal to k times the integral from a to b of f of x dx. And you can understand why that would be if you imagine, well, this thing here, the k times f of x dx, that's going to equal, according to the fundamental theorem calculus, that's going to equal k, called f, one function up, b minus k times one function up at a. Well, that's also equal to k times f of b minus big F of a, which is the same thing as what we have right here. So anyway, it's really sort of like a distributive property thing, but this is, you could just, basically what this is saying is if you have something you're multiplying it by, a scalar, you can just pull it out and put it out in front of the integral. Sometimes that makes it easier. And this one here, this is something we've already really done, and it's fairly obvious, is that if I have the integral from a to b of f of x plus or minus g of x dx, that's the same as the integral of the one, say f of x dx, plus or minus, whichever one it was, the integral from a to b of g of x dx. So I can split those two up. We've kind of been relying on that all so far without talking about it. The last two are a little weird. These have to do with even and odd functions, and if you don't remember, an even function is symmetrical. It has line symmetry across the y-axis, so it's the same on both sides of the y-axis. An odd function has rotational symmetry around the origin. Okay, well, what does that mean? That means that for integrals, what that means is that if I'm going from negative a to a on an even function, we can imagine, well, then that might be like this, negative a to a. This area here on the left side and this area here on the right side are going to be the same. So this whole thing is going to equal 2 times the integral from 0 to a of f of x dx. Right. So this whole thing just equals 2 times this part over here. Now, if it's odd, if I'm going from negative a to a, and so there's going to be the same distance from the origin. Well, whatever this is here, if we call that big A, that area, this is going to be negative of that because it's below the x-axis. So this thing, the whole thing, is going to equal 0. They're all kind of intuitive. I don't know that they're worth memorizing. But anyway, those are the basic properties of definition.